All right, next recap here is of energy conservation. So we went over a little bit more in depth in the previous problem, but we'll just go over the basics again. Energy is stored as either potential energy represented by U, which could be either like gravitational potential or elastic or electric. And that's just potential to do work, not necessarily doing work right now, but it has the potential to. And the other kind is kinetic energy, which is just moving. The energy a particle has just by moving, and it's mv squared over 2. And there's other types of like internal energy, but that's not really relevant in the problem. We're just talking about the mechanical energy, which is always conserved, meaning that U1 plus K1 equals U2 plus K2. And the type of potential energy that we'll be dealing with in the next problem is gravitational potential energy, which is Ug equals mg delta H, basically change in the reference height times the force down. So using these two equations and setting them equal to each other before and after is all we'll pretty much need to know in order to tackle the next problem on conservation of energy. All right, problem 11, it asks about a 2 kilogram object which is released from the height of 3 meters above the Earth's surface, and it's asking how much kinetic energy it has when it reaches a height of 1 meter is right here. Okay, so this is a classic conservation of energy problem where the total energy of the start has to equal the total energy of the end. So the energy is comprised of, in this situation, kinetic energy and gravitational potential energy. So K1 plus U1 equals K2 plus U2. There's no elastic potential energy, so none of that's relevant. So we're starting off with no kinetic energy because it's at rest. So K1 is just non-existent. And U1, we know that the formula for gravitational potential energy is mgh, which in this case is 3 meters times 2 kilogram times g, which is 6g equals, that's 6g joules, is equal to the kinetic energy at 1 meter height plus the potential energy at 1 meter of height. And applying the same process for U2, we see that we get 1 meter times 2 kilograms times g, which is 2g joules. To find out kinetic energy, all we have to do is solve for this. Clearly, 6g plus the blank equals, plus 6g equals blank plus 2g. This kinetic energy has to equal 4g, which we know g is about estimated to be 10 meters per second squared, so equals about 40 joules of energy, of kinetic energy, which is answer choice E.